Hello, welcome to episode 123 in the series where I'm programming an NES game from scratch. Let's jump right into it. Last time we were adding the capability for these enemies to get added at a staggered rate based on their placement on the map. So this was the initial placement, and we'd get 3 enemies in succession. But the speed at which they were spawning was too fast. So we had made some brief changes to try and add an additional timer to the game. And what we found was that timer was problematic because it was too short. And, well, sorry, there were 2 problems. The first one was the timer was too short. The second one was that when we added a new timer variable, we got all sorts of weird behavior. And that was caused simply by adding to the entity type here one more byte. We could even just save this just for the sake of demonstrating this again. So the first problem was that the range errors appeared because the struct pushed us past 255 for our index into the memory. And then the secondary problem was that we were then also having weird behavior in the game. One thing that I wanted to check was, because I don't remember what we were doing, how this is arranged, and what would be the problem here. I wanted to check where the RAM section begins. Not types config. No, CFG. There it is. NES. Let's take a look at the configuration here. Let's put it all together. I don't want it side by side. So let's see, the RAM section here starts at, oh no, okay, it's this CPU RAM, which starts at, I was going to say 6,000. That's not right, but that's for if you're using SRAM, which we're not. So CPU RAM starts at 200, and it's 600 or 600, 200 to 200. So what is it? 200 to 800 hex. And what do we have after that in the game? We don't have anything else. But the problem is, $200 is here. 800 is out of the range of what we can have, but this is where our OAM data is for the sprites. $116s, 256s. So it looks like the problem might be we're getting into our OAM data, causing the sprites to maybe go a little bit bananas, which is why we were seeing that weird flickering. If we were to change, let's change the RAM position just to prove that. So 600 is too much now because we can only go to 7FF. So let's just say it's 300. So this is purely for the sake of just testing out what I was saying, so that if we move this before the 500 range, that we are, sorry, the 400 range that we're using for OAM, that the problem goes away. We still have to reduce the number of entities that we are allowing in the game, both on the object and projectile side. So I think 1.9 was workable. It is. Let's restart the emulator here. Now it's still doing that. I'm surprised. I'm surprised that that's still a problem, given that we're at this range here now. Because all of this is sprites at 400. But it's almost like clear object entities, clear projectile entities, clear mem. Look in the emulator. Open the debugger. Come on. Open up. Thank you. Object is at 500. Projectiles is at 5FA. We're not exceeding 7FF, which is over here. So it's strange. Strange we're having that problem, unless we're doing something where... Are we hard coding anything? What's this? That's a clear... Oh, okay, so well that's a 200... Is that a 200 really? CPU stack? I don't remember where the base address of the stack is. I thought it was at 7. But NES NESDev stack register sending stack short code range page 01. Okay, so it's at 01. We're not doing anything with that. The stack is here, starting at this. Okay, so is the stack doing anything odd? It's not like growing down at an alarming rate. It's just changing, which you would expect as the game runs. It's interesting, the logic of the game seems to be running fine. It's the emulator is displaying the sprites in a weird way. I mean, there's definitely something odd going on with the with these. This all looks normal, right? Like all of these entities here look like they're supposed to. So it's almost as if draw entities was having some sort of issue with this change. Let's take a look. That's debug entities, draw entities. Oh, entity start times 9. That's not correct because it's not 9 bytes anymore. It's actually 10. So that's shifted 8 plus 1. So now we want to actually do. We want to add this twice. If that fixes it, we probably should make a note. Aha, okay. That was the problem. So we should make a note in our entities that draw entity is using the size of entity in a somewhat hard-coded way to calculate an offset, and that if you change the entity size, you've got to change the calculation there. So let's do that. Changing the entity requires changing the draw entity code because it's calculating an offset based on the size of this struct. Change this to byte. We introduce timer 2. We could even say, let's just call this data 2. It's kind of a generic I'm not crazy about that. Even do that. I'm not crazy about doing it that way and having timer broken out necessarily, but at the same point, it's not the worst thing we could do. So what we need to do now is remove all of these comments that we put in. Okay. And instead of timer 2, it's data plus 1. I think that's going to let me do that, but we'll see. It's just an offset that it would have to calculate slightly differently. Let's see if we can do that or not. Yes, great. So now we actually have our code for that little enemy thing. So let's what? That was weird. Okay, so now the enemy should spawn once we get past this little second block here, and hopefully the timing will be a little bit more spaced out. Nope. Okay, let's take a look at this, because I don't remember what we actually implemented here. I assumed that it was right, but... So we set the timer to FF and data plus 1 to 3. Alright, so then we load data plus 1. If it's 0, skip spawn processing. Otherwise, we decrement the timer and we load it. And if it's not 0, go to skip spawn processing. Otherwise, load that with FF, store it in timer, decrement data plus 1x, load the type, the X position, the Y position, add the map object, transfer the X to A, and push it onto the stack, load X with T1 to get our index, load A with 0, 1, okay. And store that. That all looks reasonable, but we also switched over to using a word instead of having a separate byte, and maybe I'm not correct in the usage there. It's totally possible. So let's take a look at that, because I was making an assumption about how that worked, but obviously something's not quite right. Alright, so we're loading. Let's take a look at this first. Oh, I wonder if doing the data plus 1 like that let's take a look at this here. Wait, what are you doing? Why? Who? Not sure why it's not showing my... Let's see, so load A is the BD instruction. Zero 0805 0705. I feel like that should work, but let's objects was at 500, so let's see, X is 10, which means it's the second, yeah, so 4A, data is 7, so 17, so from 5A to 6, 1, let's see, so data plus 1 is 8, and data is 7. This might be okay, at least code-wise. Or, sorry, data-wise. No. Why are they 2 and 3? Data. Oh, okay, yeah, that's fine. 2 and 3 and then FF. Yes, okay, that is fine. Because timer is still FF, and the 3 is data plus 1. So that's, yeah, that's okay. So A got 3. It's not 0, so decrement the timer to FE. Load A. Oh, is it maybe because it's too many frames? And then it despawns the object. Yeah. Okay. That makes sense. So it's actually working, but what's happening is because we put so many frames, FF is 255, so what is that roughly? 4 seconds, 4¼ seconds. So in the time that it travels down, it's hitting the bottom and despawning the main object, which means that it's not spawning the subsequent objects. So let's go with let's say 1C, which I think is 30. I just kind of pulled that out of nowhere from my recollection of hex here. 28. I was so close. 1E. 1E. That was without actually calculating it or remembering 100%. So I would have been very surprised if that had been right. And remember, the whole purpose of why we're doing this in this way is that we want to be able to make these enemies groupable so that when we destroy all 3 of them in the group, that we're going to end up with a some sort of condition where we can spawn. Okay, cool. Forgot about that. That's going to be 1 less, and 30 is not enough. So let's see. Let's do 60. 3C. That's what I was thinking of. Not 1C. 3C for 60. Let's see how that looks. One of the things I was talking to Bo at Soul Goose Productions about today was in-game editors. And I know that that's a common thing in PC game development, at least at this point, but we were talking about, he had showed me some stuff early on about some in-game editing work that he was doing, and it was pretty cool looking stuff, and I was curious to know how it was going. And apparently he had worked on something recently where he was using that for the entirety of the game. It'd be really cool to kind of implement some of that here so that we're not constantly having to build and rebuild, if at all possible. Why is it not flickering? That was strange. Is it because of the cloud? What was that all about? That's... Oh, okay. Yes, I remember now. It's because that's weird that it's causing that flickering on the bullet, though. It's because we're only, I think, causing flicker in the objects and not the projectiles. I still have to try out that timing that the doc sent over. All right, so that's a little bit too slow because they're making their way pretty far down the screen before the next one spawns. So somewhere in between 30 and 60 frames. So between half a second and 1 second is where we want to be. Was that explosion a loop around trailing explosion? I expect that it was, just based from... Yeah, so because we were on the bottom of the screen, the explosion looped as it kind of hit the bottom. Actually, that spacing's not too bad. Okay, but there is a problem. I don't know if you saw it there. And the problem is that if you delete, if you despawn by destroying the first enemy right away, it no longer spawns any additional enemies. So one of the things that we had tried to avoid in the way we were doing this originally was adding new sprites just as sort of placeholders for spawning. That was my thinking. But now as we go through this, you know, okay, so if we didn't want to do that, but now at the same time it's like, okay, that means that we have to track the fact that it's spawning as something separate from the actual ship anyway in the code, because if the ship gets despawned by being destroyed, then the other enemies don't spawn on the screen, which sounds obvious when you're doing it, but I hadn't really thought about that. So let's focus on the grouping stuff here first, and then we can go back to the to fixing that part in the next episode. We'll fix we'll add the ability to place an object that has no actual sprite to spawn enemies. We'll have to figure out how to make that work and have it be separate from the enemies themselves. So going back to what I was saying before, though, but in the in-game editor, it would be really cool to have something like that for the purposes of even just building the graphics, to be able to see them on the emulator or even in the NES if you provided a tool, you know, where you could use the controller, or I mean, you can even use the Super NES mouse, right? The pinout is actually the same on the Super Nintendo as the NES. It's just arranged differently. That's why you can use a Super Nintendo controller with the appropriate adapter on the NES. If you didn't see NEScape on Kickstarter by Kahan Games, he's actually using the Super Nintendo mouse as a control in the game because it's point and click, which is really cool. And so it's totally possible to read the mouse on the NES. But my point is that we could do something where you could use the mouse to modify the contents of the game in real time, and then, you know, you'd have to save it off somewhere for, you know, incorporation into the ROM later. But so what I'm trying to do here is, let's say low RAM. I don't want to. Let's say this is 200. basically we're just defining this other section in RAM that we can use. And the reason I'm doing that is because I don't want to have all my stuff in RAM with the objects and projectiles having other stuff grouped with it. So we're just sectioning off this memory at the 500, right? At the 500 address. Yep. And this stuff starts at 2. And let's just create a real simple, call it group counter. And this will be yeah, we'll just reserve our 1 byte, and just for the sake of proof of concept, we'll just use that one byte there. And what we'll do is when we are initializing the sprite here, or the enemy here, we will also store that into group counter 1420. Our usual little dance with the range errors there. Okay, so that should all be as expected. Nothing should have changed there. Great. Okay, so go back to this thing here. So this will initialize group counter to 3, and then check player collision. It checks to see if we collide with the player object, and then check bullet collision. And then, okay, so if it's a little bit thing, then we go to check collision, and where is this? Okay, so we know that we destroyed it here. We spawn an explode sprite in its place. And then let's also just decrement group counter. So let's just make sure that this all kind of works. I mean, there's no reason it shouldn't. It's so straightforward and basic that there's no reason this shouldn't work. So let's assemble this and restart, and actually look at the game. So what we should see is when that enemy spawns on screen, we should get the counter 3 here, and then as we destroy them, we should get the value 0. And we're going to wait until all 3 spawn because we have that bug. We're going to wait till all 3 appear, except that I just shot the first one. And then I didn't wait. Okay. Yeah, and you could hopefully see that as I destroyed them, the counter decremented to reflect that. And so now in a situation like that, then what you can do is you can have something where you spawn a special, object on screen, like a power-up or something, which is pretty standard for a shmup, right? Now, obviously, this is super janky because this is not handling this in a way that scales properly for the game, because we only have one counter. We're hard coding which counter we're adjusting for, so there are a lot of little changes we're going to have to make this work. The first, I'm thinking this through. The first is I'm wondering if we want to change the number of entities to support a different number of entities for objects versus projectiles. I was talking about this in one other previous stream or episode, that the number of objects on screen at any time will probably be far fewer than the number of projectiles. So we probably want to allow for fewer objects, and then the projectiles can actually be simpler structures, which will further help us to have more of them, because they generally, I don't think, will require any sort of timers or anything like that. Even if they do, I think we could get away with keeping things a little bit more simple. And the reason this is important is because we need to also track for the objects which group they're part of, in order to have the group update occur in what we're going to have here. So we'll say, I mean, based on the number of objects I think we'd ever have on screen at any given time, we could say maybe there's like 6 groups at most, so 6 bytes for that. That seems like that might even be a lot, but we can start there and always pare down or go up if we need to. And then the other thing is, let's create a new struct called projectile, and it is literally just going to have it might have like a type, because it's the type of projectile that it is. It could be, I mean, there are a couple of things. It could be that there is no projectile in that spot in the projectile list, but it could also be we might have several different projectiles for different enemies, different ship projectiles. That makes sense that we would have that. So let's leave it at that there. That's pretty straightforward. And then then we can change this, right? We can say, well, let's see, if we had 6 groups of 3, that's 18. So we can reduce the size of that quite a bit, and then say max projectiles, I don't know, you can say 30, 32. I mean, I don't actually know. We'll see what we can squeeze out of it. So now the tricky part is that because we've changed that, anything that deals with projectiles, we've got to change the code to handle that structure now, right? All right, so oh, actually, we want to do type over here. And that's that. And then it's U-bound projectiles. Be prepared for this to break substantially. I mean, hopefully not. Hopefully I will catch the things that need catching. But most likely things are going to be broken, which is okay. I'm okay with sharing the entity type right now still. I don't want to go too crazy. Alright, so process, projectile loop, and then we're going to check this there, and this needs to be this, and that, and that, and then data and timer are no longer used, so that's good. And then U-bound projectiles, and this should be projectile, so that's good. This is oh, interesting. Sorry, I'm just looking through this here. Is that entity start? Oh, that's wrong. I'm surprised that wasn't a problem. It may have been, but let's fix that. And then we're going to draw entities, and it's going to start with projectiles. So let's fix that. That's pretty straightforward, right? Because there's not a whole lot going on there for the projectiles right now. The only thing is, oh, I see. Okay. So we're reusing entity start. So this is actually now, because we're doing projectiles first, this is actually wrong. It's just 3 bytes. Let's do 4. Just to make it nicely multipliable. I know it wastes a byte, but this way it's just simple. Boom. Done, right? We do 2 shifts, that's times 2 times 4, and we're good. And we go in here and we do our thing with the projectiles, and then it recalculates it for entities, and this is times 10 now. And let me make the same note here. Requires changing the code here before draw entity. Also based on the size of the struct. Okay. So we have the entity, we have the projectile, we go into draw entities, it does the calculation, it goes through and does its usual thing here. This is all generated code, which eventually will have to get actually generated properly with these changes we're making in the tool. And then that's the end of that. That scope is for drawing objects. Size of entity. If we hit U-bound projectiles, then yep, okay, that looks reasonable. I don't know if that's going to work, but that looks, you know, like roughly what it should look like to make that transition. And I can fire my projectiles with no issue. Well, that's pretty cool. Maybe I managed to get it right the first time. The enemy should be spawning here. Alright, so other than them not despawning, or it didn't seem like it anyway, right? It looks like it hit the enemies, but then the projectiles kept going. But other than that, that's actually... that's cool. Other than that, it's working pretty well. Check bullet collision. Oh, yeah. That would matter. I'm surprised that this actually works. Objects, entity type, check the bullet against it, right? Where are the projectiles? Yeah. So we gotta replace all the struct references here with projectile instead of entity. So that it actually updates the right spots, because otherwise it will do, it's probably, that's why it's doing what it's doing. It's tracking the movement roughly right, but or correct because of the coincidence that the struct lines up there, but then the it can't despawn the projectile. So let's get that tested, make sure that that's working the way it should. Yeah, cool. All right, so now I don't know how we want to handle if we exceed the group count somehow, like the number of groups we can have. So current group is going to indicate the offset into group counter, or let's call it group counters. And so the group that gets assigned will be grabbed based on the current group counter. So like here, when we spawn, yeah, see, like this is another example of where having the sprite be the thing that tracks this is kind of annoying. Do I really want to increase the number of bytes here again? The type is a byte. We have 2 data specific bytes. Let's see. So we're checking to see if the byte is 0. If it's not 0, then we know it's not going to do spawning. Where is that? Here. Well, actually, if it's 2, so we could use. Really, we only care if it's 1 or 0. Otherwise, it could be any other value. And so what we can do is use that to represent the group counter offset. So it would be 2 minus whatever group counter. Or sorry, the other way around. Whatever the value is minus 2 is the group counter that it's currently using. So load A, clear carry, add carry, group counter, then increment the group counter so that we reserve that one essentially. There's a whole other thing of, yeah, this kind of sucks. This is not a good way either. I may have to think about this a little bit more, because the problem with this approach, I'm not sure if I need to draw it or not, but the problem with this approach is, yeah, it'll help to kind of visualize the problem. So I've got these 3 ships. When this first one spawned, the counter was 0. So we record that somewhere and we increment it to now be 1. At some point we can clear out the fact that 0 was used, right? Like, let's say I destroy all of these and it spawns a little money thing that's now floating randomly. We have these group counters that had a 3 here and it went to 0, which then triggered that thing here to spawn. The thing is that now it can be reused, right? We can reuse that for something else, but we don't really know that if we're using just a counter. The counter is a bad way to do that. We could you could loop through the counter list and see which ones are 0 and reserve the first one that's available. And because this is multi-threaded, you don't have to worry about, 2 threads. Like if this were a multi-threaded application, I wouldn't do this because you'd have multiple threads potentially trying to get into the list. You'd need to lock the list. I don't like this idea. Here, does it need to be a shared counter list? I guess it doesn't. I guess this all kind of stems back to the fact that all of these things are kind of operating in an independent way. Whereas what we would really want to do is on the map, when we get to that block, we can even use the same color so that you know what I'm talking about. So when we get to that second green block here on the map, and we want to spawn the little guy there, right? Instead of that triggering all of the following things, we have some little object on the screen that tracks what group. It doesn't even have to track the group, it just can track the counter, right? So as you destroy this enemy, it would know to modify the counter that's in there. And then you'd have your multiple. I mean, you could probably do that. You could say the parent entity is, let's say the parent entity is 2. So then you'd say, okay, so objects X, right? The objects or plus entity data, right, would be maybe the counter data, either data or data plus 1, whichever one, of X, where X is the object, the parent entity that spawned it. You could get that value and decrement it, and if it became 0, then that triggered some other thing to occur. So basically it kind of is all, because then you can have as many groups as you have entities on the screen, which obviously you're still limited by, but it's not like this weird sort of thing where you're shoehorning these groups into this counter structure, which I don't really like. I mean, we know it works because we saw, but better to track that in the objects responsible for it than kind of make it a global thing that doesn't really need to be. So why don't we leave that for next time? I know this was short, but I didn't ramble in the beginning quite as much as I usually do. So yeah, let's do that next time. We'll start with the ability to add objects to the map that aren't necessarily directly sprites, that will be able to spawn these guys, and then we can use that to keep track of these pieces of information and also have it still spawn these guys without worrying that if you destroy the first one it stops spawning the rest of them, which it shouldn't do. So yeah, so thank you as always for watching. If you have any questions or comments, feel free to leave a comment down below on the video on YouTube, or reach out to me on Twitter at Clairvis. I'm on Nintendo Age as Zelius, and I've been getting a lot of questions and people watching and feedback, and that's awesome. I'm glad people are really enjoying the series and getting something out of these videos and these explanations of how you make a game for the NES. I mentioned last time there is a Patreon. If you are interested in that, I do a patrons only kind of write-up of the video afterwards, so that I can explain sort of the Reader's Digest version of what happened in the video. Or if you just want to support this, but you're not necessarily interested in the game itself, anything is welcome. I definitely appreciate it. Spend a lot of time on these videos. Or you can pre-order the game and get access to the source code. That doesn't mean I'm not going to give you help and look at your code if you don't, but certainly appreciate it if you do. There was someone who was asking me questions and tweeting at me with code and stuff that he was doing, following along with the examples of the videos very early on, and he asked for the charom file, and happy to share it. Happy to share as much as I can, but also kind of want to put something out there for people who are interested in the game, and as I mentioned, special pre-orders for the cartridge version once this is done. So thanks for watching. See you Thursday. Remember, Thursday is the live stream at 9 p.m. Eastern. Hope you guys can join me, ask questions, talk. Yeah, and thanks. See you around. Take care. Bye.